Okay, this video is going to go over equivalent elements between electrical and mechanical systems. So the equivalent elements are broken up into three different areas or topics. First are parameters. So things like this, we had a mass in mechanical systems for translational mechanical systems. Well, the equivalent to that in an electrical system is going to be an inductance represented by an L with units of hertz. Now, for our spring constant mechanical systems, the equivalent to that is a capacitance in a electrical system, represented by a capital C with units of farads. It's actually that the spring constant is the equivalent to 1 over C, but generally we just say their equivalents, K and C are equivalents. And then finally, for our damping coefficient for mechanical systems, well, damping in the electrical world is captured by resistance, capital R with units of ohms. And then for our states, before we had a velocity to describe our masses, now we have a current to describe our inductances. These are both flows. Current is represented by capital I or lowercase I in some cases with units of amps. And then our net deflection or deformation represented by D delta X. In electrical systems, that is a charge Q or X with units of coulombs. And then finally, for our effort term, what our effort was in mechanical systems was a force. Now it is a voltage. A voltage is what drives electrical systems, capital V with units of volts. And just like with mechanical systems, where power is an effort times a flow, it's a force times a velocity. The same thing is true for electrical systems. So in those, power is a voltage times a current. And that covers equivalent elements for electrical systems.